Hello, I'm Paul Beckwith. Yesterday I discussed some of the consequences of this tremendously persistent and deep trough that is presently over North America, causing very, very cold temperatures in large parts of the US. And I'm going to continue today with some of the climatology and meteorology to actually show you what is going on. I checked the number of people in Texas without power, and yesterday it was about up to about 4.5 million people, with over 5 million in the country without power. This morning, it went down yesterday to three something, 3.2 million people or so, and this morning when I checked, it was higher again, and then it's dropped to about 2.7 million people this afternoon. So there's still millions and millions of people that are without power. For some people, it's the second, even third day. It's very, very cold, so they're not able to heat their houses. Pipes are freezing. The refrigerated food must be going bad. And I believe in Houston, there's a potable water advisory, a drinking water advisory, because the purification plants don't have power to run, so they have water shortages now in Houston. What is really frustrating to a lot of people is they're in the suburbs of these cities, these huge cities, and they can still see the skylines of these cities, Houston and other big cities in Texas, completely lit up while they don't have power themselves. It must be extremely dystopian and frustrating to them. So anyway, let me get back into the meteorology with this video. So this is a movie that's playing from tropicaltidbits.com. Okay, and it's the global forecast system 2-meter temperature anomaly, and it's relative to the 1981 to 2010 climatology, so the 30-year average. So it's a temperature anomaly relative to that. Okay, so what it's doing is it's cycling from February 14th to about March 4th or March 5th. So I'll stop it. Let's go through here. Okay, I'll stop it at the end of March here. Okay, so this is February 14th, 2021. This is the 2-meter temperature anomaly, and what you can see is, okay, the jet stream is coming like this. Okay, so the U.S. is in this deep trough going all the way to the Gulf of Mexico, and these are the temperature anomalies. So this purplish, pinkish color is down here, about 20 degrees Celsius warmer than normal. This is Celsius, not Fahrenheit. Meanwhile, the high Arctic and over Greenland, it's about plus 20 or so. It's up in there, plus 12, plus 14, 16. You can look at the scale here. It's very, very warm up in this region. And there's also a huge warm spell here across Asia, northern, Russia, all the way over here to, deep in Europe. Very, very cold. Now I can double click, and this is February 15th, February 16th, February 17th, today, and you can see this cold is persisting across the U.S. This is the 18th, still cold, but it's easing a little bit. 19th, the forecast model is showing still cold. That's Friday, February 19th. The 20th, the 21st. It starts to clear on the 21st. 22nd, and then another little cold comes back. 23rd, 24th, 25th. And now they have a huge heat anomaly, okay? So it goes from those really, really bone-chilling temperatures to anomalies on the other side. So we've got these deep reds here, or pinks. We're talking about temperatures, up to maybe 10 degrees Celsius warmer than normal here, okay? And then if we continue, February 26th, 27th, 28th, the more cold coming by. So what you can see, and here we are colder than normal, nothing like what we've seen, March 2nd, March 3rd, March 4th, and then I think it recycles back to the beginning. Okay, so let's leave this running for a minute. So you can see the cold persistent down in the US in that trough of the jet stream, and then it's swept out to warmer air and then colder. This is a weather whiplashing or weather wilding that I've often talked about. So that's in this region, you know, where this huge brutal cold snap has knocked out large chunks, at least a third of the Texas power grid. You can look up in the high Arctic here. So this is Greenland. North Pole's up here somewhere, roughly over here, where my pointer is. And you can see that it's staying persistently much warmer than normal. Now, this has been happening for years, but people haven't cared about this because they don't live up in the Arctic. But, you know, for the most part, the large bulk of the population. So people haven't cared about it, but now it's directly tied to the cold outbreaks in populated areas. So this area here stays pretty much consistently warm. Over Greenland, it's mostly much warmer than normal, but there is some cold that does sweep through. I talked about the U.S., what's happening there. If we look over in Europe, okay, this is Eastern Europe. It's also staying persistently cold. Occasionally some warm air sweeps through. More over in Asia, in Russia and Siberia, extremely cold, and warm temperature anomalies to the south. Okay, so you can see how basically these jet stream waves, the ridges have warm air. So let me stop it. Let's stop it here, or go back to today's date. We're about today, so there's a powerful trough, and then there's a ridge up here, right up into the far Arctic, very warm air, you know, deep trough here, ridge here, and so on. Okay, so the jet stream, these Rossby waves as they circumvent the planet, are causing this, what we're seeing here. So it's very telling here, the connection between climate change and cold and warm outbreaks. Okay, so we're getting very, very strong frontal boundaries between warm areas and cold areas is one thing. We're getting a very fractured and broken convoluted jet stream because we see pockets of cold, pockets of warm around the planet. And if you happen to be in a pocket of cold extending far to the south, then you get what we're seeing in Texas. The infrastructure gets hammered and people are miserable. There's enormous consequences to people and their livelihoods. Okay, so this is the key factor here. This was tweeted out here. If you're on Twitter, follow this gentleman, and you can get lots of images. So let me start at the beginning here. Okay, so make sure you check out my website, paulbeckwith.net, and please consider donating to support my work. This video is a continuation of my video from yesterday on brutal cold rocks United States from coast to coast. I'll post it, you know, I'm posting it the next day. Okay, my Facebook page, paulbeckwith.9. Okay, just follow me. I'll clean it up soon. Right now I'm at the limit, but I'll open up space for people. I've been tweeting out a lot of stuff, and I want to talk about this Stefan Ramsdorf chain of tweets, but I'll do that in a minute. Lots of information on what's happening, the consequences to people with this cold spell. So Houston is facing dire water shortages because there's power outages, and it's pushing Texans to the limits. Power outages have knocked out the water plant, so now there's water shortages, and Houston is under a boil water advisory. Okay, I'm not going to talk about all of the details here, but this is an ongoing nightmare. It said Wednesday morning there were nearly 2.5 million homes and businesses without power. No one knows how long the outages will happen. Okay, there's lots of images and lots of photos. In terms of the power, if you Google poweroutage.us, this gives you near real-time updates. So it's showing Texas 2.754 million people without power. this, let me see if there's an update. Yeah, so 417, 2.6 million. So it's gone down about 100,000 people. This morning I saw this at about 3.4 or so. And during the peak of the outage, this was at 4.2, 4.3 million people. Okay, so this is an ongoing issue. This number rises after it gets, at night it gets colder, lots of frozen lines, lots of transformers out. And then during the day, they put maximum effort into getting people online, so the number goes down and then it goes up. So this is gonna bounce around like this for a while. Hopefully it's cleared up. Today's Wednesday. It started Sunday night. Hopefully it's cleared up by the weekend. But that's a lot of people without power for a long period of time. Climate reanalyzer. This shows the image here. But what I really want to do is show you. Okay, and I did show you this tweet here. Showing the movie. So this is a whole bunch of climate reanalyzer type images. They're actually from tropicaltidbits.com showing the anomalies. So I'm going to go to tropicaltidbits.com and I want to show you some additional stuff. This is an excellent site for getting the meteorology. So if we go to thermodynamics, 2-meter temperature anomaly. This is the temperature anomaly that you can see here. Okay, at the moment. The most up-to-date one. You can get the temperature in shaded. Now this is in degrees Fahrenheit. Okay, so you can see the temperatures. Florida is warm, but you can see, how these are temperatures in Fahrenheit. You can see where the cold line comes through, and when you get up here, 0 degrees. These are in Fahrenheit in this case. Okay. Upper dynamics, we can look at the jet stream winds, 250 millibar pressure. So this is the jet stream winds here. And if you go back to the thermodynamics and look at the 2-meter temperature anomaly, or actually the 2-meter temperature shaded, you can see how it's tracking the jet stream location very closely. Okay, so the jet stream acts as a wall. The cold, dry air is here, the cold Arctic air rather is above the jet stream line, and the warm humid air from further south is below. Okay, so these are the upper dynamics. You can get all kinds of halfway up the atmosphere, 500 millibar heights. Lower dynamics, you can get mean sea level pressure anomalies, and you can see the very high here, a low here, the depth of the low here. And precipitation moisture. So you can get the 24-hour accumulated precipitation, for example. Okay, so there's lots of information on tropical tidbits. I showed you Earth Null School. Just Google Earth Null School. I'm looking here at the winds at 250 millibar, and you can see them here. So the jet streams you see at 250 millibar. If you want to see what the polar vortex is doing, you need to go to lower pressure, which is higher up in the atmosphere. So here you can see the polar vortex. It's actually split. There's one rotation here, one rotation here. So the big difference, when we talk about polar vortex, we're mostly talking about the high stratospheric movement of air. If we talk about the jet streams, we're at 250 millibar, which is the height roughly the troposphere, the division between the top of the troposphere and the bottom of the stratosphere. This is the temperature. This is the air temperature at the surface, and you can see the cold regions and the warm regions, and you can see that warm regions go far up into the Arctic. So here we go, we're 83.5 degrees latitude north, and it's above zero, okay, from a powerful ridge. Now, Stefan Ramsdorf tweeted out a couple things, so there's some good images of the deep cold here. There's an image of, the jet stream dropping far over North America, and he talks about some papers and some of the connections between the stratospheric polar vortex and the jet streams and the temperatures on continents and stuff. And there's some references to 3 papers, the different stratospheric. These are all open source. You can get them. And I'm going to do a separate video just on the science of these 3 papers, which explain a lot about the polar vortex and this heat outbreak. Thank you for listening.